No, most of the lunar missions were targeting the area around the equator. And the equator is well lighted and compared to South Pole regions. So, South Pole regions are rather frozen and go to very extreme temperatures. So, we think that there is a lot of information that is to be gained by an in situ exploration of South Pole region, especially about the upper crust and mantle. Because of the large number of craters that are there are chances that by exploring the lunar surface itself, we will be able to gain further information about the origin of moon and even the origin of the solar system. So that's why there is a totally renewed interest in exploring near South Pole. But the South Pole conditions are difficult for a lander to go there and do an exploration. But then that is a difficult task that we have taken up in the Chandrayaan 2 mission as well as in the Chandrayaan 3 mission. So we are planning to land around 69.3 degrees towards south. And this area we will be exploring for 14 days, one moon day. And we have payloads both in lander and rover to explore the surface of the moon as well as the seismicity and the ionosphere close to the surface. So with the the payloads in rover are tuned for doing experiments and finding out the chemical composition of the regolith by different methods, and that also will give us a lot of inputs about the formation of the moon and probably, as I earlier indicated, formation of the solar system itself. So the scientific community is greatly thrilled about the information that we will be gaining from the exploration of South Pole.
So the mission timing of the mission is very lengthy in Chandrayaan 3 comparing to the other missions. What was the reason for that? Because the Luna is the upcoming mission of the Russia. It's taking less time than the Chandrayaan. What is that?
So we have a proven LVM-3 rocket. We have a proven capability that. And if you want to look at the highest mass that we can carry to the moon and do the research there, the number of payloads and the rover. And this is the only way we could have done it with our existing launcher. Any other way would have either impacted the mass that we could have carried, or the number of payloads and the experience we could have carried, or rover that we could have carried, and with the available launcher. So this is a very well thought out decision to go like this, because it gives us the greatest opportunity with the resources that we have. And the resources we have chosen because the launcher is a very reliable launcher. LVM-3 is an extremely reliable launcher. And for this mission specifically, we haven't done any change to LVM-3. So we have the full heritage of that rover and the full confidence that we can get from that launcher. And this is the right decision and the most wise decision that one can take given the resources. And you can see that taking a longer time does not affect any performance. Okay, and we get more time to carefully look at each step, validate it, carry it out, then again verify that it has been achieved. So we have been moving steady in each step, and we have made sure that each step has been carried out perfectly so far. So in a whole, a direct ascent and transfer missions like Luna 25 will require a bigger rocket, and it will give less time for any verification of the achieved statuses and then taking corrective action. So that's what I would like to, comment on your question.
And upcoming projects like Aditya and the Gaganyaan, what was the status?
Yeah, the upcoming projects are well on course because Aditya is ready and waiting for launch in the first week of September. And it's also a very interesting mission. In fact, after looking at moon, we are directly going to look at sun also. And that it is going to orbit an area, position called L1, where the Earth's gravity and sun's gravity will be equal and opposite and cancels out. This point is called L1, and Aditya will be having an orbit around L1, and this point is around 15 lakh kilometers away from Earth. That is, Moon is around 3.8 lakh kilometers. So this is a 15 lakh kilometer away from Earth, and Aditya will be taken there. And Aditya will definitely use the experience that we have gained from Chandrayaan 3. And next one is the great Gaganyaan mission that we are been working for some time now, and things are getting fairly ready, and we are going to have the first uncrewed mission sometime early next year, and all activities towards that are steadily progressing. And that also will be done using the LVM-3 vehicle, which is modified for this purpose. And the rocket also has been made human rated with certain changes and certain redefinition of the operating points. With this, the rocket is now getting ready for doing this mission. And that will be the next mission for LVM-3 vehicle. We also have designed a crew escape system for this mission, which will take the crew away in case of any problem with the launch vehicle. And the crew module also is, first crew module to fly in Gaganyaan is also getting ready. And we will be surely having the first Gaganyaan launch. It is called as GX mission now. It will be carried out in the first half of the, first months of the next year. And before that, we will be doing one test vehicle mission, which actually will be looking at the abort performance. So we will be simulating conditions for the abort in the atmospheric region, and we will see how our crew module is taken away to a safe distance by the crew escape system, which we have planned. And in that mission, we will be able to ensure that the crew escape strategy is good and validated. And there will be few more test vehicle missions in order to validate various other abort conditions also.